G'day, Mr. Honey here. Before we begin this video on matrix translations using matrices, I want to clear up something I said earlier regarding matrix multiplication, and that is that matrix multiplication. Let's first by start saying let A, B, and C be 2 by 2 matrices. Okay. Now, I said that the commutative law does not hold. Does not hold for matrix multiplication. Okay, and that's correct. That basically says that if we do A times B times C, that does not equal, say, changing around the order, C times B times A, and it also doesn't equal B times A times C, and it also doesn't equal B times C times A. Okay, so if you change the order around, then you're going to get a different result for matrix multiplication. Now, here's the thing I said sort of incorrectly, is that we also have this other thing called the associative law. The associative law, and it actually does hold. The associative law does hold for matrix multiplication. Okay, this law basically says that A times B times C. So that's saying that you do A times B first. So if we do A times B first, and then after we've done A times B, if we multiply C, that is the same thing as if we'd first done B times C, see there in brackets, so B times C was done first, and then the matrix A was then multiplied. Okay? So all that's happening here is either you're multiplying the A times B matrix first and then C second, or B and C first and then A second. Okay, but the order is very important. Order is important in terms of how they are written, but you can do either ones first as long as you maintain the order. So see on this second one where you've done B and C first, A is still on the left. Okay, A is still on the left. So it's very important, and we'll be coming to use that piece of information in this video. Okay, so what this video is all about is using matrices to do your translations and your reflections and your dilations, and also rotations now. Okay, matrices to do translations, reflections, dilations, and rotations. Okay, so let's start over here with a set of axes, X and Y. Okay, so let's suppose that we start with points here, okay? And I'll call this point, well, it's obviously at 2, 1, okay? Now suppose I moved that point so that it was here at 3, 3. So I'm going to call it P dash now for 3, 3. So I moved this point to there. Okay, they're not 2 points, it's the one point that's been moved. That's why it's P and P dash, the moved point. So what's happened is we've moved this way, 1, to get from 2 to 3, and we've moved up. So we've moved to the right 1, and we've moved up 2. So what we've done is some translation. So we're going to start with translations. So for translations, if we're doing this in a matrix form, we'd say, well, here's our original point. The point is at x, y, and we're going to do some sort of translation to get to the point P dash and we'll say x dash y dash for the places where the coordinates where they've moved to. So for the translation, first you'll start with the point where we're going to end up at this point. So we're going to end up at p dash x dash y dash, and the way we've gotten there is if we have, let's suppose in general we're moving to the right k units and up h units. Then to do that, we start at our original points x, y, and we add on, in the x direction we're adding on k units, and in the y direction we're adding on h units. K and h. So for in this example, what we've done is our final points, p dash, our final points is x is 3, 3, 3, 3, and that's our original point here, our original point. So our original point is 2, 1, and to get from 2, 1 to 3, 3, we needed to add on 1 unit going across and 2 units going up. Or just written purely as a matrix, we've got 3, 3 equals 2, 1 plus 1, 2. Okay, so that's how we do our translations. We do translations by adding. So translations are done by adding. These other things, reflections, dilations, and rotations, are all done using matrix multiplication. Okay, so let's start that off here. Okay, so let's do our reflections, dilations, and rotations. And I'm just going to tell you that you need to refer to your textbook table, which has all of these the different styles of reflections, dilations, and rotations listed. But we're just going to do a few examples so that you can get used to using them. So first off, let's do a reflection across the x-axis. So reflection across the x-axis, the thing we need to do, and the key is here that we are always doing these they are called pre-multiplication. So I'll show you what it means. To do a reflection across the y-axis, we need to be using a 1, 0, 1, minus 1. Whoops, 1, 0, 0, minus 1 matrix onto our points. Let's plot a point actually. X, Y. Let's say it's a point here, 2, 1. So a reflection in the y-axis makes us, in the x-axis, makes us want us to take that point to here, where it should be, to minus 1. That's what we want to occur. So if we try it, so here's the general form, x, y. We'll bring it over to the x coordinate should be the same, the y coordinate should be negative. Okay, so this will be what happens. So let's do it using our example. So 1 times 2, 1 times 2 is 2, plus 0 times 1 is 0, so nothing there. And 0 times 2 is 0, 1 times minus 1 is minus 1. And that is what we get over here. So there we go, reflection across the x-axis. In a similar way, a reflection across the y-axis would have taken us this way to this point negative 2, 1. So what we would want is to go from x, y, and end up with a negative x value and the y value being positive. The way to do that is with the following matrix, minus 1, 0, 0, 1. So what's happened is the place where the minus 1 is has changed. So that's a reflection across the y-axis. Now, we often always want to do reflections across key lines. So this is the line y equals x. So if we have a point here at 2, 1, if we reflect it across this line, the x and y coordinates swap, giving us 1, 2. So that's reflecting across the line y equals x. So So a reflection across y equals x. We're trying to swap the x and y coordinates. X. So it'll become yx here. Swap it over. And the way that that will occur using matrix multiplication is 0, 1, 1, 0. So we can try multiplying that out if you like, or you can take my word for it. Let's use an example perhaps to show it. So 0 times 2 is 0, 1 times 1 is 1, 1 times 2 is 2, plus 0 times 1 is 0, so we've got 1, 2. So these values here have swapped. So there's an example of a reflection across the y equals x line. Okay, so there are our main reflections that we have there. So let's look at now a dilation. Dilation. So basically a dilation is either stretching something in the horizontal direction or in the vertical direction. So this is a dilation from y-axis, from y. This is a dilation from the x-axis. Okay, so suppose we have, let's set up our axes again, and we'll put in the same point that we've been discussing. It's 0.21. Okay, so if we want to dilate something by say k units. Alright, so first let's try and dilate it in this way by k units. That means the point will move here and become k times 2, 1. Okay, so we've dilated in k units in that direction. Or if we wanted to dilate upwards by k units, the point will be up here, and the coordinate will be 2 and k times 1. If we want to go up. Or let's do a specific example. Okay, so we start here at 2, 1, and let's say we want to dilate dilation of a factor of 3. That means we'd be getting 6, 1 as our coordinate point. Or if we want to go up by 3, our new point would be 2, 3. So let's try this out. So we want to take our original point from x, y to b. So let's do the dilation from y. From y, so that's doing the cross way, stretching it out across. So that means we want it to be k times x and y. There. The matrix we multiply by is k, 0, 0, 1. So this means that y gets left alone, and here x gets multiplied by k. And if we wanted to do a dilation from the x-axis, so go in this up and down direction, it would just be the opposite, 1, 0, 0, k, x, y equals x, k, y, like so. So if you want, let's do some of these examples. Let's start with the from y, so the one going across. So we're doing a dilation of 3, so we'll have 3, 0, 0, 1, multiplied by x, y, by 2, 1. Let's do our actual example. So here we have 3 times 2 is 6, and 0 times 1 is 0. And then for this other point, we've got 0 times 2, and 1 times 1, 6, 1. And that's the point that we expected to have. So that one's done. And now our second example. So the point that we expect is 2, 3 equals, okay, 1 times 2 is 2, and 0 times 1 is 0, so it's just 2, and 0 times 2 is 0, plus 3 times 1 is 3. 2, 3, just like we expected. So there are our dilations as well. Now the only thing we have to go is a rotation. let's get some extra space. All right, rotations. Okay, rotations are a bit more complex, I suppose. Okay, so we start with our original point at 2, 1. And for a rotation, we go clockwise, because that's the way that angles go, as you well know. So if we were to do a rotation, this distance here, that length, that's sort of our radius, if you like, that radius length will be kept the same. Okay, that radius length will be kept the same, and we'll go around in however many degrees we like. So this one, so radius is kept the same, and we just go around in that direction. For this one, it's probably easiest if you just follow the formula, which I'm happy to prove to you in class, but I don't think I'll do that right now. So basically, to do a rotation clockwise by theta amount of degrees, you need to multiply something by cosine of the angle you want, by and minus sine of that same angle, and sine of the angle, and cosine of the angle. Multiply that by your original coordinates, and you will get, just use the dashes here to signify our new coordinate point. So that will be shifting around with the same radius length, however many degrees you're after. Okay, so just follow that, that matrix multiplication and you will find the answer. Okay, so now I want to think about doing combinations of things. So let's do an example. So find the point okay, so find the point or the resultant point after the point 6, 2 has been reflected across the x-axis and undergone a dilation of 2 from the y-axis. Okay, find the point after the point 6, 2 has been reflected across the x-axis and undergone a dilation of 2 from the y-axis. Okay, so what's happening here is we're starting off with our point, which is 6, 2. Then it's been reflected across the x-axis. So we'll do an x-axis reflection. So that is a 1, 0, 0, minus 1 reflection there. So refer to your table for that. And then, so that's that bit done, and undergone a dilation of 2 from the y-axis. So now we've got to do this dilation of 2 from the y-axis as well. So that is a k, 0, 0, 1. Okay, so notice that I started here and I added things onto the left side. So I'm doing pre-multiplication is what's going on here. Now you remember using the associative law that I mentioned at the very start of this video. It doesn't matter if I do these two matrix multiplication bits first or if I do these two bits first. It's up to you. I generally start on the right hand side and then go sort of backwards. So I'll show you what I mean. I'm just going to leave this one alone, k0, 0, 1, and I'm going to do these two bits. So 1 times 6 is 6, 0 times 2 is 0, 0 times 6 is 0, minus 1 times 2 is minus 2. Now I can do this bit. So notice that I left this on the left hand side. Now k times, oh whoops, dilation of 2, so it's not k, it's 2, isn't it? 2 instead of k. There we go, that's much better. So 2 times 6 is 12, and 0 times minus 2 is 0. 0 times 6 is 0. 1 times minus 2 is minus 2. So there's our final answer. Now let's do it if we, suppose I had have done it in the other way. Okay, so I'd do it in the other way now. So I'm going to do these first two bits together. So 2 times 1 is 2. 2 times 1 is 2. 0 times 0 is 0. So it's just 2 there. Then the next one going across, notice that I'm going to get a 2 by 2 matrix when I multiply these two together. The next one that's going to go in this spot here is 2 by 0 is 0. 0 by minus 1 is 0. Now the next spot, this one here, 0 by 1 is 0, and 1 by 0 is 0. This final spot, we have 0 by 0, which is 0, and 1 by minus 1 gives minus 1. Now I'll put this back here, 6 and 2. 2 by 6 is 12, 0 by 2 is 0, 0 by 6 is 0, minus 1 times 2 is minus 2. So you can see either way that I did it, either if I did these two first, which is my personal preference, or if I had have done these two first instead, which you can do, you get the same answer as long as you make sure that everything remains in that same order. That's basically all there is to it. Just remember to use the table in your textbook. Yeah, that's it. So best of luck. That's it for this topic on matrices. So I'll look forward to seeing you again in our next topic.